On with the sine law.
Again, here we're going to be dealing with triangles that are not right angle triangles, so we can't use regular SOHCAHTOA. We went over the cosine law in the last video, and today we're going to go over the sine law. The sine law tells us that for any triangle, I can pick a side and divide it by the sine of the angle across from that side, and it'll give me a ratio. I can do that for any of the sides of my triangle and their corresponding angle across, and it's always going to give me the same value. This is true for any triangle. Notice even for right angle triangles, we could do this. Here we've got three different ratios. You're only ever going to pick two because it's kind of hard to do an equation when you have a second equal sign. The second row is just that first equation set, but rearranged so that you have your denominator and numerator switched from before. So if you need to know which one of these options to pick, do I want to pick the top one or do I want to pick the bottom one? Pick the one that has the variable you're looking for in the numerator because it makes the algebra just a little bit easier. There is no right or wrong way to pick these. You can, as long as you just pick two. Always have either signs on top or always have sine in the denominator. You're going to use the sine law when you have triangles that have two angles given and any side. So notice it doesn't matter the order that those angles and sides come in. Or you can use the sine law when you have two sides and an angle that's opposite from one of them. So this looks similar to the cosine law where we had side angle side, but the order in which we know the values matters. So if we know two attached sides and then the angle that's across from one of them, we would use sine law. In this example, we can see I've got an angle, a side, and an angle. So I know that I can use sine law here. And for this question, we want to find the side length between angles A and C. And according to this triangle, that's across from angle B, which makes this side my little b. Side B is what I'm looking for, so I'm going to use the ratio that has B on top of sine B. And now the question is, do I want to make this equal to A over sine A or C over sine C? So we have to take a look at our triangle and see what information is given. I have angle A, but I don't have side A. And then if I look at C, well, I have side C, and angle C isn't given to me, but I could remember that 180 minus these values is going to give me that last angle. So since I have a really easy way to get angle C, I'm going to use this particular version in my sine law. Once I've picked which equation I want to use, I just need to take my values from the triangle, so angle C, angle B, and side C, and plug those values in. Now to get B by itself, I just need to times both sides by sine 25. And remember, sine 25 is just a number, so it's not a difficult algebraic thing to take care of that. You can calculate the number first if you wanted to, and then deal with transferring that decimal value across. But remember, when we're dealing with sines and cosines, we keep a lot of decimal places. Now remembering that sine of 25 and sine of 75 are individual numbers, they are not related to each other. I can't try and simplify this 25 over 75 business. The 25 and 75 aren't related to each other. We're just going to type all that into our calculator and get our answer. With this calculator, I have to put the angle in first, so I'm going to do 25 sine times that by 30, get my answer on top for my numerator, and now I'm going to divide that by 75 sine and hit equal to get 13.1 for my side length. I still want you to use diagrams when you're drawing your triangles out to do these problems, but sine law gets a little bit tricky because if you take a look at the triangle that's even given to you here, I've got 25 degrees in what clearly looks to be a corner that has an angle bigger than 90. And then over here, I've got 80 degrees in this tiny little wedge size of a triangle. We were actually drawing what's going on with the information we were given. I've got 25 degrees and then 30 centimeters and then 80 degrees. And I know that this somehow is going to make up a triangle. I don't know this side or that side in order to start building the rest of this triangle for my diagram. So there's something to be careful with any of these cosine or sine laws. to not draw a triangle that looks like this and then just go with it and always assume that your diagram is an accurate representation of what's going on with the triangle. Here's another triangle where I'm given an angle and then a side and then the angle. So we know we're going to have to use the sine law here. Go ahead and start setting this one up for yourself. Pause the video, see how the setup works, and see if you can come back and match up with what we have here. You've probably caught on by now that once you have two angles known in a triangle, you can get the third one. And in this question, side length QR relates to side P in our diagram. So I know that I'm going to need P over P, and Q is the side length that's given. So I'm going to use P over sine P equals Q over sine Q. Doesn't have to be ABC as long as my sides are on top and my sines are on the bottom. From here, we just plug and chug. Multiplying both sides by sine of 75 degrees, which is just a number, and that's going to get P by itself, and the rest is just calculating with our calculators. And you should end up with 8.6 as your answer for this triangle. Here's an example where I have a side attached to another side and then an angle. So an SSA triangle, and we can use the sine law for this as well. In this example, we're also going to try to find the angle instead of the side length. So we're going to use one of those sine ratios where we've got sine B on top. Looking at the information given in this triangle, I also have my angle A and side A across from each other. So I'm going to use sine A as my third part of this equation. Once you have your equation set up, plug in your values and get to work. Pause the video, see if you can get sine B by itself. And you should have something that looks like this. Remember, I can't just try to get B by itself. It's stuck with sine. So I need to get everything else isolated, and then I'll deal with that inverse function business to get the angle out of this sine function. Over here, I've got 60 over 80. Normally, I'd say to simplify that, but since we're just going to throw all of this into our calculator anyhow, it's not such a big deal to leave it that way. I'll do 60 times the sine of 125 in my calculator. I'm not going to hit clear. I'm just going to go ahead and divide that answer by 180. So I'll get some big, long, obnoxious decimal value. And now I'm going to do the inverse sine function. I'll write it down just so you can see what I've done. So I've only written down 3 decimal places, but I'd want to do the calculation with more, which is why I leave the values in my calculator. And now I'm going to hit second function and sine to get my actual angle. And so that gives us B equals 15.8, and we can round that to 16. Here's another example where we're going to try to solve for an angle. Let's go ahead and take a look at all of our options for sine ratios and then start looking at them and figuring out which version we want to use. I know that all 3 of these values are equal to each other, but now I need to take a look and say, well, what information do I actually have in this question to start solving this? So I do have side length J, and I do have side length H, and I have angle H. So I have those values. G is the one that I'm looking for, but if I used sine G over G, I have 2 values that I don't know, so I can't use this ratio with any of my other combinations. Any equation that we use can only solve for 1 value, and here I've got 2 values I don't know. So to start out, we're going to have to use this set. Once I get a second angle, then it's easy enough to solve for G just using 180 minus this number, and then third angle pops out just from that calculation. So go ahead and set up the ratio of sine H over H and sine J over J. I'm going to pause the video and see if you can get sine J by itself and solve for angle J. And once we've got J figured out, that's all the hard work done. The last part is just to get G. And we're going to do 180 minus all of the other angles. So we get G equals 75 degrees. I'm going to stop this video here and do another one to finish off this unit. We're going to be looking at sine law in what's called the ambiguous case. I'll see you there.